Hello and welcome to another one of these ADD videos. Today we're going to be looking at part 2 of the introductory journey to chemistry. So what are we going to discuss? We're going to look at an atom and we're going to break it down into the subatomic particles. What are the three main subatomic particles? The first two we're going to discuss are found in the nucleus, and they are your protons and your neutrons. And their mass is as follows. Let me zoom out for a little bit so you can see what's going on here. And let's see. Let me get the highlighter going. So the mass of a proton is right here, 1.6726 times 10 to the negative 24 grams, which is very, 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 very small. This is all naked to the eye, cannot see it. The charge for a proton is a +1, and the number of protons will determine the identity of your element. If all the atoms have the same number of protons, then they're going to be a specific element and behave in a similar manner. The symbol for proton is either the H plus with the 1 and 1 charge and mass, and here we have a P there for proton. The other thing we got is the neutron, and the neutron is kind of a buffer, if you will, for all those protons that are jam-packed in the nucleus. If you remember, like charges repel each other, so the neutrons wedge themselves in between the protons to buffer the repulsive force found in the nucleus. Here's the symbol, there's the mass, and that leaves us with the third subatomic particle, and that is the electron. The electron floats in these shells that are found around the nucleus, and it can well, first let's go through the mass. The mass is 9.1 times 10 to the negative 24, or 27, sorry, grams. I got distracted by my puppies again. And the charge is -1, and here's the symbol, okay? So what happens here is we have the protons and the neutrons in the nucleus, but the electrons, they are in these spherical orbit patterns, if you will. So it's basically a shell that's representative of a row or a period on your periodic table. Each one of these shells is, and it can house a certain number of electrons. Like the first one could only have 2. Then there's another shell that pops up, and these are all spherical shells within each other. Concentric shells means there's one within the other, just like that. Okay, so what we have going on is the electrons have different probabilities of floating around in these shells, and there's a different density or a different probability associated with different locations. And in between each of these shells is what's called a node, or a nodal plane, in which there's 0 probability of finding an electron. So it's like one sphere, and then there's no way you'll find an electron for a small region of space, and the next sphere. And then you can find electrons anywhere three-dimensionally in the sphere. Pretend that's a sphere. And then another node, and then another sphere, and it goes on and on like that. And we'll discuss that more when we talk about the quantum numbers later on in a different video, okay? So what you should keep in mind now is that these electrons are just going to be orbiting the nucleus just around random paths in these different shells, okay? So there's probabilities associated with these paths, and different things play into those probabilities. And if you continue to study chemistry, you can get into that, but it's nothing that belongs on this introductory video. So those are the basic subatomic particles that form up the atom. You can go even further to a quantum level with quarks and neutrinos and antineutrinos and stuff like that. That's more quantum physics. We're doing general chemistry. So here are a few other terms that you should be familiar with. The atomic number. The atomic number is going to be the number of protons found in the nucleus, and it's going to be responsible for determining the identity of the element itself. The atomic mass has to do with isotope abundance. Real quick, let's go with isotopes. What are isotopes? Well, in nature, you have different versions of elements. There's carbon-12, there's carbon-13, just a few different versions of these elements exist at different percentages, okay? And what the atomic mass is the average of all these different versions of carbon, for instance, found in nature. There aren't that many, don't think there's an infinite number, there's just a few different types. But they're just found in different percentages, okay? And we'll talk about how to calculate all that in the isotope abundance videos. But just know that atomic mass is not the same thing as mass number. Those are two completely different things. It's often confused for one and the other. Okay, atomic mass is that average with the isotope abundance I was telling you about, whereas mass number is the number of protons plus the number of neutrons. Okay, so make that distinction in your head clearly, please. That way you don't make that mistake in the future. Typically, the way you'll see the element written is like this. Let me highlight this. So this yellow box that just popped out, you're going to have whatever element it is. You're going to have the mass number up here, and you're going to have the atomic number down there. Okay, and in doing so, we have a way to calculate the different subatomic particles, the numbers of different subatomic particles. So for instance, let's say we have this scenario here in which we have element X that has a mass number of 100 and an atomic number of 25. Well, all you do is you look at the atomic number, and that'll give you the number of protons, which is 25, and also it'll give you the number of electrons, provided it's not an ion of any kind. Then to get the number of neutrons, well, you take the mass number of 100 minus 25, and that'll give you the number of neutrons, which is 75. Okay, so mass number minus atomic number is neutrons, atomic number is protons and electrons. And we'll discuss the exceptions to the rule when we look at the example videos. Okay, so mass number, protons plus neutrons, atomic mass, average of the different versions or isotopes found in nature. Here, one more distinction I forgot in part one of the chemistry videos is the difference between a compound and a molecule. Whenever you have substances that are formed by two or more elements, those are called compounds. So this glass of water has compound water inside the glass. Now I can look at one specific molecule of H2O where it's also got pretty much the same definition as complex particles formed by two or more elements, but the difference is we're looking at just one pair of H's and one oxygen, as opposed to the compound of water. Okay, make that distinction in your head. But you will find that in nature, the elements exist as different forms, different states. We'll talk about the properties next in part 3 of the Chem Basics video, in which we'll discuss the differences between the solid, gaseous, and the liquid phases, and intensive and extensive properties, and other things of that manner. So I hope I've further clarified your confusion you might have with chemistry basics, and make sure you check out part 3 and as well as the examples. Yes, there are problems you can work out with chemistry involving math, so make sure you check out the example videos and go through those as well. Okay? Practice, practice, practice as always. I hope I've clarified things for you. Thank you and have a nice day.